Assalamu alaikum wa rahmatullahi wa barakatuh. You are welcome to another edition of the online class. Today we are going to be looking at another topic, which is effect of electricity on matter. As we all know, we have some substances that allow electricity to pass through them, and we have some that will not allow electricity to pass through them. Now, based on this knowledge, we classify elements into two types, that is conductors and non-conductors. Now, also based on this, we are able to classify compound into electrolytes and non-electrolytes. We are going to be looking at each of them separately. Let's look at conductors. Conductors, they are elements that allow electricity to pass through them because they have free mobile electrons. Examples are magnesium, iron, zinc, copper, aluminium, etc. And then we also have a non-metal too, which is graphite, because it has mobile electron, and that is why it's able to also conduct electricity. Now, the non-metals, they are the opposite of the non-conductors. They are the opposite of the conductor. Another name for non-conductor, we call them insulators. Now, what are insulators? They are the elements, I would say substances that does not allow electric current to pass through them. Example, we have sulfur, phosphorus, oxygen, and so on, like that. Now, if you look at them, basically they are non-metals. They don't allow electricity to pass through them. Now, we also have semiconductors. The semiconductors, we call them metalloids. They are intermediate. That means they have property in between the conductors and insulators. Example, we have the silicon, germanium, arsenic, and so on, like that. Then we have the electrolytes. The electrolytes, they are compounds that conduct electric currents in molten form or in solution, and then they decompose in the process. Unlike the conductors, they don't decompose, but the electrolytes, they decompose in that process. Now, these compounds, they can only conduct electricity, like I said, when they are in molten form or in solution. Now, examples are hydrochloric acid, tetraoxosulfate acid, sodium hydroxide, potassium hydroxide, the sodium chloride, that is the normal salt we use in our homes, sodium tetraoxosulfate C, copper 2 tetraoxosulfate C, and so on. These, they are examples of electrolytes because they allow electricity, they conduct electricity whether they are in multiform or in solution. Now, non-electrolytes. The non-electrolytes, they are substances that do not allow electricity to pass through them, whether they are in solution or they are in molten form. Example, we have sugar, paraffin wax, kerosene, petrol, alcohol. All these, they don't allow electricity to pass through them. They don't conduct electricity. Now, these electrolytes, we can classify them into two. We have the strong electrolytes and the weak electrolytes. The strong electrolyte. they are the compound that ionize completely in water. Example, we have hydrochloric acid, triazonitrate 5 acid, potassium hydroxide, sodium chloride, potassium chloride, and so on like that. They are strong electrolytes, so they ionize completely in water. We also have the weak electrolytes. They are compounds that ionize partially in water. Majorly, they are weak acid and bases. For example, we have the ethanoic acid, the triazocarbonate 4 acid, triazosulfate 4 acid, and so on. Now, also these electrolytes, their conductivity varies. Now, the conductance of a solution, it depends on the nature of that solution or the nature of that substance. And then also, the conductivity is also directly proportional to the number of hydrated ions in the solution. When I say hydrated ion, the number of ions, the number of ionizable ions in solution. As we have seen here, you can see H2SO4 there. When it ionizes, it gives 2 hydrogen ions and then 1 sulfate ions. That means it has 3 hydrated ions. The triazonitrate 5 acid, as we have seen, the triazonitrate 5 acid, when it ionizes, it has only 1 hydrogen ion and then 1 nitrate ion. So it has 2 hydrated ions. While in the ethanoic acid here, you see it has 2 hydrated ions. Now, the question is, which one conducts electricity more? The H2SO4 is a strong electrolyte, and it also produces 3 hydrated ions. So it will conduct electricity most, followed by HNO3, which is also a strong electrolyte, but it only produces 2 hydrated ions. And the last one, the least here, is the ethanoic acid. Although it produces 2 hydrated ions, but it is a what? A weak electrolyte, and so it will only conduct electricity partially. So the H2SO4 is the one that will conduct most, followed by HNO3 and then the ethanoic acid. So that is that on electrolytes. Now, let's move to electrolysis. Electrolysis is the chemical decomposition of a compound either in molten form or in solution when electricity is passed through it. That is what electrolysis is. Now, on this electrolysis, we are going to be looking at some terms in which we are going to be referring to when we are explaining the mechanism of electrolysis. We have the electrolytic cell, in which this is the cell in which the electrolysis takes place. The electrolytic cell is a cell that is made up of a pair of electrodes dipped into an electrolyte held together in a suitable container and connected to an external electric source. Now, this is what is known as electrolytic cell. Inshallah, when we resume, it's going to be one of our projects. It's very simple. The materials we are going to use is very simple. We can easily source for it around. So we are going to see how it looks like and how it works. Now, the next one we are going to be looking at is electrodes. The electrodes are the conductors through which current enters or leave the electrolyte. We have two types of electrode. We have the anode, which is what? Is a positive electrode through which current enters the electrolyte. And we also have the cathode, which is the negative electrode through which current leave the electrolyte. Now, mechanism of electrolysis. The mechanism of electrolysis is based on the ionic theory, and it depends on whether the electrolyte is in molten form or in aqueous solution. Now, in the electrolytic cell, the electron move along the wire from the negative pole of the battery to the cathode. So the cathode becomes electron rich and then is negatively charged. And so therefore, the positive ions will migrate to the cathode, positive ion, cations, and that is why we call them the cathode ions. So the positive ions will move to the cathode. In the anode which is attached to the positive pole is what? Becomes electron deficiency. And so the negative charge, or the negative ion migrate to the anode, and that is why we call it negative ions, that is anion, and that is why we call them anode ions. Now, when a molten electrolyte is connected to an external current, these ions, they migrate to different electrodes depending on the nature of their charge. As we all know, the positive ion will migrate to the cathode, while the negative ion will move to the anode. While the negative ion will move to the anode. Now, at this electrode, each of these ions, they are discharged either by gaining or losing electron. Now, let's consider the electrolysis of molten sodium chloride. Since it is not in solution, that is, it's not in aqueous form, the two ions that are present there are sodium ion and chlorine ion. Now, when current is passed through it, the positive ion, that is the sodium ion, move to the cathode where it is being discharged, and then the chloride ion move to the anode where it is being discharged. So at the anode, there will be production of what? Of chlorine gas. Now, if you look at this equation very well, you see that sodium ion receiving one electron to form sodium, while the chlorine being a diatomic gas will receive two electrons. We give out two electrons to become chlorine gas. But because chlorine is a diatomic gas, chlorine will release two electrons. So these two electrons will also be accepted by the sodium ion. So that means we are going to have two sodium here, so that it will receive two electrons. And here also two chlorine, each of them will give out one electron to become two. And so Sodium is deposited at the cathode while chlorine gas is liberated at the anode. But if it is electrolysis of sodium chloride, that is aqueous sodium chloride, we are going to have two ions, two positive ions and two negative ions. That means one positive ion from sodium chloride and the other one from water, which is hydrogen. And also we are going to have two negative ions, one from the salt, which is chlorine, and the other one from water, which is the hydroxy ion. So the question is, which of them will be discharged? Which of the two positive ions will be deposited at the cathode, and which of the two negative ions will be discharged at the anode? So that one will take us to the factors that determines the preferential discharge of ion in the electrolysis. Preferential discharge of ion at the anode, at the electrode during electrolysis. I'll repeat myself and say the ions that will be discharged, because this time around we are having two positive ions which migrate to the cathode and also two negative ions which migrate to the anode. So the one that we discharge, that one will take us to factors that determine the preferential or selective discharge of ion at the electrode during electrolysis, which we are going to look at in our next edition of our online class. Assalamu alaikum wa rahmatullahi wa barakatuh.